Hi, this is our first learning video for OLI Mod 8. I'm actually going to just talk about a few things that you would have done on your own here just to make sure that we are all on the same page. The mean is what you used to call an average, so that's the more common name. And what's really important is that we understand the thing that is balanced on each side of the mean is the distances. The distances to each piece of data are going to be the same on both sides of the mean. And to really see that in action for yourself, I wanted everybody to go ahead, just pick any four numbers and see if they could demonstrate this by themselves. So to do this and to just make sure you don't think I've concocted the numbers in any way, I'm actually going to go to the data sets view in StatCrunch, and I'm going to use the views numbers over here to just give me my numbers. Let's see, I'm going to take that first number. I've got a 2 and a 7, so I'm going to use 27. I'm going to use a 4 and then a 31, and to get my fourth number, I'm going to go down to the next views there for the Thanksgiving poll data and pull the 79. So those are my four numbers. To find the mean, we know just like an average, you add them up, you divide by 4. So this comes out 35.25. And this number line I've given us, I want to put the mean on there first. So 35.25 is maybe about here. Let me draw us a fulcrum. There is our balancing point. So again, that is at 35.25. And let's go ahead and locate all of our data. So we have a point at 27. So about right there. Let's number that, 27. Another one at 4. A point at 31. And our last point at 79. Okay, so let's take a look at the distances from the mean to each of these points. So here, let's start going all the way back to 4. So that distance, we could take 35.25 minus 4, and we get our distance of 31.25. For our next point, back to 27. So again, subtract, and we have a distance of 8.25. And then for our last point, 35.25 back to 31 is a distance of 4.25. So from the mean, our total distance below the mean, add up our three numbers, 31.25 plus 8.25 plus 4.25 gives us a total of 43.75. And then how about to the right? Well, we only have one piece of data to the right, and the distance from center to that piece of data at 79 minus 35.25 is exactly 43.75, showing us that the sum of all the distances below the mean is equal to the sum of all the distances above the mean. And that is always going to be the case when you have the mean. That is what it balances, is those distances on each side. Now that gives us perhaps a very visual way to solve this next learn by doing activity. So Perhaps you solve this in a very algebraic way. Nothing wrong with that. You would take the quiz scores that you have, 87, 72, plus 85, plus the new one that you're looking for, divide by 4, and set that equal to the average of 80 that you're looking for. Then, of course, to solve, you're going to multiply on both sides by 4, and then subtract each of these remaining constants to get your exam score. And that's a perfectly fine way of doing it, but I want to think of it really more in terms of this balancing point. So let's take each of these exam scores, 87, 72, 85, and think about their characteristics in terms of distance. So we'll think about the distance below this mean of 80, and then our distance above that mean of 80. So 87 is 7 units above, 72 is 8 units below, 85 is 5 units above. So with these 3 exam scores, we've got a total of 12 distance units above, and we need to balance that with the distance units below. So we're going to need a piece of data that is 4 distances below the mean, 4 distance units, so that we have a total of 12 on this side as well. What exam score would be 4 distance units below 80? Well, that would be 76. So that is the exam score we would need for that average of 80. The next learn by doing, I've given you a hint there. I definitely want you to think from a graph point of view about using that idea of a balance point to find the mean, but they really want something very exact here. So maybe think about from that balancing point what you think it should be, but then you can go ahead and figure out what each piece of data is in this data set from the dot plot, and from there you will be able to calculate the mean that they're looking for. Oops, got a blank page there. Moving on, our second measure of center to address is the median. The median is balancing the number of pieces of data on each side. So the mean balances distance, and the median balances number of data values. So for this did I get this activity, 17 pieces of data means that you will have 1 in the middle and then 8 on either side. So that's what you're counting here. Let's see, here's 1 piece of data, there's another one, so that's 3, 4, 5, 6, 7, 8. So all you know is that the median is going to be somewhere in this bar. It's going to be a piece of data that is somewhere between 16 and 18, because that is the spot that puts 8 pieces of data on each side. Okay, next video we will take a look at how to decide which one of these measures of center, the mean or the median, will be best for our data set.